Good afternoon. My name is Silvano Coriani. I work in the Azure Postgres team. And yeah, welcome to the Postgres for SQL Server Professional session. The attendance is actually more than what I expected, so it's a good, good sign. You will find, it's a very packed hour of content. I'm not sure I will be able to go through all the demos, but you will find them on my GitHub site under Azure Dev Summit 2025. So in case I couldn't make it, please go there. I'm trying to document and to provide some kind of step-by-step guidance for demos there as well. Cool. Okay, so a little bit about me. I've been working on SQL Server and Microsoft technologies for a long time, more than 25 years. And more recently, I came across a bunch of these surveys, like the last 4 or 5 years, where Postgres is actually showing up as the most popular, the most kind of loved database technology among the developer audience, which basically took me a little bit by surprise, so to speak. So what I did was, first of all, I switched to the Postgres team from my previous team that was working on SQL Server. And then what I tried to do was to kind of try to understand what kind of skills and practices that I learned over the years working on SQL Server could be reapplied across those many areas in the Postgres space, right? Right now, I'm working in our Azure team where we are delivering a managed service based on Postgres called Azure Database for Postgres. I don't know if you are aware, but that's a pretty rapidly growing service within the Azure platform. And we'll talk a bit about our managed offerings later in the session. But at the beginning, I want to kind of draw some parallels between the two technologies so that you can, in a way, if you have expertise around SQL Server, you can map at least the most important concepts and practices between the two database servers. So we will go through some architecture, and then how we deploy, monitor, manage, and programming, Postgres, and then we will move again looking at how we are trying to make essentially developers' life easier with our managed offer in Azure. Okay, so first of all, the two products have a lot of commonalities. Actually, they put into a single project who started in the 1970s in the UC Berkeley. This project was called Ingress and was driven by Dr. Stonebreaker, and who was taking EG code relational database work and basically created the first incarnation with this Ingress project. Right, this project then became Postgres, which was the successor of Ingress, as the name kind of implies. But in the meantime, Sybase, which was again founded around 1980, implemented basically a commercial product based on the same concepts. And then Microsoft partnered with Sybase to create SQL Server. So you can think about the two technologies having like a common root. Starting like at the end of the 1980s. Actually, the first release of SQL Server was not built for Windows, was a OS2 release. And at the same time, around pretty much again the same year, the first OSS DBMS was released, right? So even the timelines are actually pretty, pretty similar. The first release that I've been working on was actually SQL Server 4.2 on Windows NT. That was the first release on Windows. And in the meantime, Postgres took the SQL language. Before 1995, basically the language for querying database was called Quell. And then, they adopted the SQL standard, and from there, actually, Postgres was one of the kind of highest in terms of standard compatibility in the industry. For those of you who remember, then SQL Server was completely rewritten around 1998, and SQL Server 7.0 was introduced. And SQL 2025, I only put some of what I think are the key milestones from SQL Server, because SQL Server 2005 basically started introducing things like the SQL OS, so this layer on top of the operating system for dealing with scheduling, memory management, and so on. Then 2012. Always On was introduced for kind of high availability. Then 2017 was the first release on Linux, right? A very important milestone because now even SQL Server was kind of multi-platform. And in 2025 we have SQL Server, which is positioned as the cloud and AI database in the industry, right? Postgres had a series of releases in the meantime, and the most important capability in Postgres is its extensibility, right? The ability for people to actually write components that run within the database engine and extend, its capabilities. So things like new data types, like JSON and others. Things like management capabilities were firstly prototyped around, creating extensions and then incorporated into the engine. And today we have the version 18, which is probably in the industry the most kind of extensible and powerful open source database available. So what are the key differences? This is a bit of an old architecture diagram, but I picked this up because it's simpler to understand. So in SQL Server, applications and client machines are connecting through a network interface. There is this layer called server network interface, which is basically available across different protocols, so it can be used with TCP, named pipes in Windows, and so on. And that's basically where our client interfaces are exchanging the infamous TDS, tabular data stream protocol, and receiving and invoking commands. Then, commands are basically parsed and optimized through the optimizer, which is a part of the query processor. And then, the query plan is created, and query plan is executed. And, the operations in the query plan are basically delegated to the storage engine, which is responsible for picking up, tables, row sets, doing the joins, and such, right? And if data are available in the cache, of course, data will be used in the cache. Otherwise, basically, the buffer manager will pick pages from various files in the database and load them in the cache. In SQL Server, each database has its own transaction log, which is a big difference with Postgres, as we will see later. The database files can be organized and placed across different I/O subsystems. So to optimize, for example, we can put the transaction logs on fastest hardware and the data files on different hardware and such. So if we move to Postgres, Postgres is quite different, right? So Postgres, first of all, was born on Unix and Linux operating systems, and BSD, which is a derivative of Unix. The biggest difference is that Postgres is a multi-process architecture. Right? So there is one main process called Postmaster. Postmaster is listening on a given TCP port, and every time there's a new connection, Postmaster is forking and a new process is created. And all the processes are basically sharing what is called shared memory, right? Shared memory is where buffer pages, so pages that were read from disk and loaded in memory, are stored, and a bunch of other buffers are there, like temp buffers, wall buffers, and so on. And those buffers are basically used by your own connections, connection processes, so-called back-end processes, and a bunch of other utilities, like the Wolf writer, which is again responsible for writing data in the transaction log, auto vacuum, and a bunch of other utilities that are basically there. So in a Postgres, we will see better later on. So a server is called database cluster, and within a cluster, we have multiple databases. Every single database, of course, has a bunch of schemas, tables that belongs to schemas, and other objects like functions, procedures, and so on, right? But there's a single wall, there's a single write-ahead log, which is basically making all those recovery operations that on SQL Server can be done on a database per database level. Here, instead, you can do that on the entire server. Otherwise, you are basically losing consistency across the data, right? So those processes that we were seeing previously are taking dirty pages from the memories and writing down in the transaction log, are then checkpointing to the various database files and such. Even from a physical standpoint, basically each cluster has a base directory, which is called usually PG data. PG data is where all data from all databases resides. Within the PG data, you will see a bunch of subfolders with numbers. Those numbers are basically database IDs. So each database has a folder, and within a folder, you will see a bunch of other files with a number on it, and those files belongs to tables, indexes, and other objects, right? Plus, there are a bunch of additional files that are there to map like free space, for example, within existing files and stuff like that. And then there are a bunch of system folders, like, for example, where the statistics are kept, where other global variables and global objects and such are stored. And then there is this concept of table space. Those of you that are familiar with Oracle, this is a similar concept. For optimizing your storage layout, you can actually create database files outside of the base directory and place them, like, for example, in your fast storage array on everywhere in the system where it makes sense. And in this PG underscore table space folder, you will have basically links. You will have basically syntactic links, symlinks to the folders that are actually storing the data. Right? So that's the way basically the engine is working behind the scenes. So some fundamentals in terms of key differences, right? SQL Server, the one that we know and love today, was designed on Windows, was taking basically was taking all the capabilities like multi-threading and so on that Windows is providing, while Postgres, again, was born on Unix and Linux, and it works on Windows, but definitely not recommended for production systems. And the biggest difference is this multi-process versus multi-threaded architecture. There are threads within the Postgres community that are looking into how to make Postgres multi-threaded, which would optimize a bunch of internal capabilities. But this is standing like years, and there's no concrete plans actually to move to a different architecture. Postgres, as I was saying, has very high standard compliance. Basically, is conform to most of the mandatory features that SQL 2023 ANSI standard is actually complying. It's running everywhere. It's running on different hardware and processor architectures, from 32-bit to 64-bit. From ARM to Intel to actually PowerPC and a bunch of others. while SQL has been ported to Linux using this concept of platform abstraction layer, but actually runs on, for now, on x64, and there are rumors that will be ported on ARM as well, but not now. A big difference is this concept called multi-version concurrency control. So SQL Server was born with concurrency control based on locks, right? And optimistic and pessimistic locks. While in Postgres natively, there is this concept of row versioning, essentially, right? So basically, every time a record is updated, a new version is created, right? And the old version basically is defined as a dead tuple, right? At some point, all those dead tuples will form a lot of kind of occupied space in your database, and then you need to actually clean it up. And there is this concept called vacuum, which is basically cleaning all your kind of bloat in the database. In SQL Server, this is not happening. Even if in the latest releases, row versioning has been created, snapshot isolation has been introduced, and so on. This is completely managed by the engine, so you don't care as an administrator about that. So this is a big difference because, from a Postgres perspective, vacuuming is actually one of the most delicate processes. There is auto vacuum, of course, available, but depending on when auto vacuum is kicking in, it can create issues, locking and such for applications. So, as I was saying, a lot of capabilities in Postgres, like in the indexing space, in the data type space. So from arrays, ranges, special data types like geospatial, vectors that have been very popular recently for AI and such, JSON, and so on. And together with that, a bunch of different indexing techniques, B-trees, and a bunch of other specialized indexes like Bloom indexes and so on were created and introduced. And actually, when you create a new extension, you can define your own data type and your own custom indexes, right? So basically, the platform is completely open in this regard. But SQL Server has a lot of built-in capabilities. All the high availability and disaster recovery capabilities are available out of the box. Always on, clustering, backup restore, and such. Of course, you have similar availabilities in Postgres, but out of the box, the vanilla open source bits for Postgres, you have a lot of manual work actually to be on par with what you can do with SQL. And of course, over the years in SQL, a bunch of additional services like analysis services, integration services, and so on. None of this is available in the open source vanilla version of Postgres, but a lot of tools from the community have been created, and in some cases they are actually competing with the entire kind of data engineering space with what SQL Server provides. So how we deploy Postgres? So in Windows, we have the typical installing mechanism for native Windows programs and services in this particular case. You can also, of course, distribute SQL Server in containers, Linux containers in particular. Linux containers are a little bit heavy. To give you an idea, I think 1.7 gigabytes is the smallest Linux Docker image for SQL Server, while on Postgres, the smallest one is, if I remember correctly, around 250 megabytes, right? So big difference in terms of how to move bits around for deploying on containers. You will see, I have a number of links here that are explaining how to deploy on containers and so on, but we actually created an extension for VS Code, which is making all of this very easy to do. Like in this case, for example, you can right-click, create new server, and you can create an Azure database or a local Docker instance, right? And if you have Docker installed, actually the extension is checking if Docker is available, and then you can create a new one, right? My container, I can give it a name, a password, database name, and create, and boom. So the database is there, right? This is, of course, it's a Docker container. If we check here, this is the container that have been created for me by the extension. But this is making very, very easy to start practicing, interacting with Postgres from your existing, dev machine. The only thing you need is to have Docker in place and the Postgres extension that we recently released in the Postgres team. There are many different deployment practices. Like, for example, there is a very nice Kubernetes support. There's an operator that is called kubergress, which is basically giving you the ability to deploy your Postgres cluster with primaries and secondary and streaming replication between the two. So basically a production-ready system in literally seconds. Right? And then, of course, you still have to configure your storage for production systems, making sure that it's performing and so on. But it's making deployment very, 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 very simple. In terms of cloud support, both, if you're coming from SQL Server, pretty much every hyperscaler has SQL Server support. Azure, of course, but even Amazon, GCP, Alibaba, and a bunch of others. For Postgres, in addition to these vanilla Postgres services available on hyperscaler, there's been a bunch of derivative services from Postgres that are wire compatible with Postgres, but that can provide additional capabilities. Like, for example, transparent scale out, things like CockroachDB. And a bunch of others. They provide additional capabilities, but they are fully compatible with your application, right? So, which is a great thing because you have a lot of different options. From a management perspective, I agree that SQL Server was universally known for simplifying management, right? There's been an investment, a continuous investment to make SQL Server very easy to maintain. It's basically managing memory dynamically, so it's shrinking and growing memory depending on the usage, even from a file, from a database size perspective, and so on. That's different in vanilla Postgres, right? As I was saying, it's a lot more manual, right? So you have all the primitives in place, you have all the building blocks, but you need to understand, again, those tasks in terms of maintenance and understand how vacuum is working, if it makes sense to do it automatically or manually, depending on how critical in terms of concurrency your system is. Even backing up and restore, things like restore point in time, which in SQL Server is very easy to do for a database. It's doable in Postgres as well, but you need to understand exactly how you can do the recovery process. You need to set up things manually, and then you need to practice a lot with that, especially in production systems. So from a management perspective, I definitely encourage you to look at more. What are the key management tasks that are required for keeping your Postgres up and running and survive to hardware failures, software failures, and such. From a monitoring and troubleshooting perspective, that's an interesting competition, quote unquote. SQL Server, as I was saying, is offering things like DMVs, dynamic management views, all the views and functions under sys. DM exec and so on are reporting a lot of the internals of the database that are critical for you to debug query performance and the overall server health. Postgres is offering something very similar, right? So there is this concept of cumulative statistics system, which is basically offering a number of internal functions and tables that you can query in order to understand how your server is actually performing, right? And I do have a bunch of examples here. There's a file in my demo folder which is basically giving you the ability to query like user activities, right? The activity monitor in SQL Server, it's very similar in concept to the PG stat activity table in Postgres, right? Where you can understand how many connections you have. By the way, connections are an important point in Postgres because, as I was saying, every new connection is spinning up a new process, and a process has a lot more overhead compared to a thread pool as it happens in SQL Server. So one of the settings that you have in Postgres when you are deploying a new instance by default is max connection, and is set to 100, right? Of course, those are default settings, and in your production system, you need to understand exactly what you're doing. And by the way, there are some services, like pgconfig as an example. So pgconfig is a very interesting one, is a configuration builder, essentially, right? So depending on your operating system, your architecture, the number of CPUs, memories, and so on, and the kind of workload that your system is intended to be optimized for, right, is giving you a bunch of configuration parameters that you can cut and paste in your config file in Postgres, which is where basically you are defining all these settings, and it will give you a well-tuned system for that particular workload. Right, like as I was saying, depending on the number of CPUs, for example, the maximum number of connection is quite important, and it is quite proportional, right? For example, in our managed system, we are giving you, depending on the size of your instance that you are picking to, an amount of maximum connections available. If you need more, you need to typically use a connection pooler in front of your server, because when Postgres is reaching the maximum number of connections, your next clients will basically fail to connect, right? So PG Builder is one, dbtune is another very useful one. You will see a bunch of those in my files in that repo that I was pointing at the beginning. I already mentioned about like backup restores and so on. In Postgres, you have two concepts of backups: logical backups and physical backups. Right? There's an utility called pgdump that can easily take your existing database and dump it, even in a compressed format, in a folder, in a file, and then from there you can restore with pg restore that database. This is a logical database, right? It will not give you the transactional consistency that is needed typically in a transactional backup. Right? In order to do that, you will need to have, like what you do in SQL Server, a base backup of your data files, plus a continuous archiving of your transaction logs, of your WAL files, right? And this basically means that you need to orchestrate these operations, like taking this base backup, so copying the base files and copying the transaction log, archiving the log, and then from there, the moment you need to restore, you need to set up basically a new system or the same system, put it in recovery mode, copy physically the files in the base directory that I was showing you previously for the data files, and then basically start the redo process that is applying all those transactions to the database files, up to the point where you are specifying, you can specify a point in time in terms of restore, but you will restore the whole server, not the single files. And it's a delicate process that I definitely encourage you to practice if you want to use this in production. So from a programmability perspective, You see the lists are quite kind of different here. Postgres is offering a lot of nuances from a programmability perspective that have been developed over the years. You still have procedures, functions, and triggers, same as in SQL, but then you have more advanced concepts like, for example, schema, like table inheritance, right? You can table inheritance means that, like you do with your object and classes in your programming environment, you can actually derive a table from another table and only specify, those deltas in terms of schema and so on. The rich JSON support. It's been, I think, it's not a secret anymore that in Azure, our essentially MongoDB offering is actually built on top of Postgres using JSON as a kind of storage format, and it's happened to be more performing than the native Mongo engine, right? So this is because the JSON capabilities within Postgres are very, very efficient. But there are a lot more, like spatial geotypes, like geographies and geometries. And again, these can be extended, right? It can be extended because every new extension can effectively extend what the engine is doing. Even in terms of data types, as I was saying, we have composite types, right? You can create a address type which has a street, zip, city, and so on. And then you can treat that as a new complex type, right? Or as individual columns within your tables. The arrays, it's another great example. Or ranges, where you can map and define if ranges are overlapping or not overlapping. So there's a lot of semantic also, which is helping application development in this implementation. And again, indexes are, there's no concept of actually clustered index in Postgres, right? So there is a difference that sometimes can be important for application developers, because clustered indexes are actually ordering rows within, physical rows within pages with that, order, that index key. This is not happening in Postgres. So you need to make sure that if you are expecting a certain order in the rows that you are specifying, you always put the order by clause in your queries. Right now, there is no great column store support in Postgres, unfortunately. So there are a bunch of initiatives, a bunch of prototypes, I would say unfinished prototypes to a certain extent, but I'm sure that over the next kind of month or years, a column store equivalent, and for those of you who use SQL Server know how important is column store for analytical queries, right? It's a game changer in that regard, and I think it's a matter of time for having that in Postgres as well. From a security perspective, okay, so the concepts are very similar. You have users in Postgres, they are called roles, and you have groups, of course. You can define basically permissions. It's pretty similar in that regard. On the Postgres side, you have a lot of different authentication providers that you can spin up. So in that sense, is a little bit more flexible, I would say. We have column and row level security, encryption at the column level, at the partition level, at the storage level, and such, right? So I would say in terms of security, the two are similar. Auditing is a different story, right? So auditing, there is a well-known famous extension called PG Audit in the Postgres side for doing auditing, but I would say the one in SQL Server is a lot more robust and integrated with the engine compared to PG Audit in Postgres. Tools. So here is where the community is actually shining on the Postgres side. So you've seen the new VS Code extension that have been recently released. Postgres out of the box ships with a command line tool called PSQL. It's very widely used because you just need to SSH into your box and you start query and interacting with the database. You don't need anything else. But then there are more rich tools like pgadmin, like dbeaver, and a bunch of others. In SQL Server, we know even SQL Server is switching to VS Code recently, and to the great extension that they released as well. Then there is SQL Server Management Studio, which is used by millions of SQL Server developers and so on. But in tools, this is where I think Postgres is really shining. Like, for example, out of the box in Postgres, you have a benchmarking tool called pgbench. And then the community has created a lot of monitoring tools, like, for example, pgtop, which is similar to the top or htop utility in Linux, and is basically giving you what are the Postgres processes, which one is consuming what kind of resources, if it's disk, memory, CPU, and so on. Very, very simple to use, and really straightforward in terms of monitoring and benchmarking your systems. But there are literally hundreds. Within the PostgreSQL.org, you will see there's a tools section which is capturing most of the third-party and community tools created there. I definitely recommend you to take a look because there's a tool for pretty much everything. And from an application development perspective, at the high level, so there is support for pretty much the same operating systems and programming languages. We have, of course, a .NET, an ADO.NET, a data provider, which is maintained by folks in our own .NET team and also from the community. We have support for pretty much every single language, both on low-level drivers, so connection, command, reader, and so on, but also for higher-level frameworks like SQL Alchemy, for example, in Python, Entity Framework, of course, Prisma, and a bunch of others. Microsoft also developed recently this tool called Data API Builder. I don't know how familiar you are with this. It's a pretty simple application or process that you can configure for a given data source. Can be Postgres, SQL, and others, and basically is offering you a REST and GraphQL endpoint that your applications can interact with without the need for having native drivers that are talking to the database. It may not be the most efficient way of data access for highly transactional applications, but in many, many other cases, it's definitely very simple to use and is removing any dependency from kind of lower level stuff, right? You create your application middle tiers or front end, calling into Data API Builder APIs, and everything else is basically done and taken care by the tool. Cool. Okay, so what we did in Azure was taking the rich kind of ecosystem of Postgres in terms of extensions, data types, and so on, and wrap it around kind of managed services in terms of security, in terms of availability, in terms of kind of automation, and so on, right? So. Our flexible server, so it's flexible server is the Azure Database for Postgres product for now. In the future, we are planning to have different implementations and different services. But basically, what flexible server is doing is taking the Postgres engine. Actually, it's using a container image for Postgres. It's loading in a VM. It's attaching premium storage, premium storage disks, and basically this is forming an instance. And the instance, of course, is available is from a networking perspective to internal and external tools. You can run on VMs, you can run on AKS, app service, and so on. And behind the scenes, as I was saying, we are managing high availability, meaning we are continuously backing up Postgres databases in zone redundant backup storage, and we are archiving logs and such so that you can, at any time, automate your recovery process with a click, actually with a API or CLI command, right? And we can deploy on a single availability zone or across availability zones, and basically we guarantee, as I will show you later, we guarantee 5 nines availability using streaming replication to a hot standby server in different availability zones. So again, backup, we provide like 5 weeks of data retention, so you can do point-in-time recovery or hoops recovery within 5 weeks. We can also do long-term recovery, so you can do long-term backups, and then store your backups pretty much for how long you think it makes sense. And you can restore directly from APIs, the portal, CLI, and so on. Point in time is, again, very simple. You pick up the server that you want to recover. You define what is the point in time you want to recover, and then you will recover in a different server. Because as I was saying previously, in Postgres, you have to recreate a new server in order to do that. Again, by deploying standby servers into different availability zones, we provide high availability setups, right? So we can provide actually more than this. We can provide a lot of read replicas in different geographies, right? So this is similar to what Azure SQL Database also has. So you can create, so this is a bit updated. Now we can create 5 replicas, but out of each replica you can create additional 5 replicas, right? So you can create a lot of replicas, cascading replicas actually, and this is both for like read offloading to another like server. So read-only workload will hit a different server while your transactions will hit your primary. So reporting and analytics and so on and so forth. And also you can do disaster recovery because you can promote the read replica to a new primary in case you are basically losing the entire primary region and you don't have a way to actually recover. AI. So I was mentioning extensions. We created an extension called Azure AI, and this extension is basically interacting with our Azure AI services. So we can interact with cognitive services, or how it's called today, language services, and so on. We can interact with large language models, or we can interact with any other kind of ranking and any ML model that you deploy in Azure, right? So in this case, what you can do is basically store your vectorized data in pgvector, which is the vector extension providing vector data type in Postgres, and then you can interact with Azure AI to do all sort of similarities, semantic search, translation, and data enrichment, and so on and so forth. This is native. You do all of this within SQL, within the SQL language in your Postgres in Azure. For now, I think Azure AI and all the new indexing capabilities are only available in Azure, so you cannot install those extensions on a different environment. So these scenarios that are enabled are, again, like natural processing, chatbots, like the infamous chat with your data scenario. You can do anomaly detection, recommendation systems, and so on. Another integration which is unique for Postgres in Azure is ability to read and write from Azure storage accounts. So you can create this extension, then you can set up which storage accounts you want to talk to, and then you can do insert or select from CSVs, and Parquet format is also coming. So basically, you can extend your database outside of your managed disks within Azure to external files and so on. And the query engine is actually capable of joining, filtering, and do all the great stuff that the database is doing together with the local data. How do we create Postgres in Azure? You can use CLI, and you have like flexible provisioning capabilities. You can create VNets, you can create private endpoints, and so on. Or if you are just testing, you can say AZ Postgres Flexible Server create. And everything else basically is taken care by the CLI command. It will give you back basically a connection string, and then you can start connecting with your application and work with that. But of course, as developers, we love infrastructure as code. So we have Terraform modules, we have Bicep support, Ansible, ARM templates. So you can integrate your Azure database for Postgres within your deployment pipelines. Even with Aspire, actually. In Aspire, there are specific Aspire modules that lets you create and provision new Azure database for Postgres and basically integrate your cloud and your on-prem environment natively. Here, just an example of a Terraform script, which is basically using resources like Postgres Flexible Server, databases, and so on and so forth. Or, of course, we have support for all the SDKs, Python, Java, .NET, JavaScript, Go, which is missed here, and so on. Once we have deployed, then we can connect using the PSQL utility and just pointing to basically the URI of our server, or we can use AZ and do AZ Postgres Flexible Server Connect, and then basically you will get authenticated into your server. You can start querying and administering your server this way. All the key metrics are basically exposed from the engine into Azure monitoring. Right, so you will see, of course, resource utilization, CPU, memory, but also like DB connections and a bunch of other metrics like IOPS, throughput, and so on. I was mentioning all the different PG stats _star tables that you can use to monitor, but we actually did something different in Azure. What we did was to basically borrow the concept of query store from SQL Server, right? And the idea is that as the database is running on a like temporal manner, we are actually persisting, basically extracting statistics and persisting statistics into the Azure _sys database in your server. Right? And basically data are organized in time series, right? Which means that you can, like, for example, look at a particular query and see, for example, performance degradation over time. You can do A/B testing, like, for example, test server A, test server B with different configurations, and see how a given query is performing in different options. We are actually capturing resource utilization, query duration, and wait stats. So the reason why the database server is waiting for an external resource like disk or memory and so on. And this is basically critical for you to administer your server. So basically, you will have a bunch of tables that you can query, and then you can configure, of course, query store in terms of the frequency of collecting stats and aggregating stats, what kind of queries you want to capture, only the top queries, all queries, how much time you want to retain data into the Azure _sys database, and so on. Super, super interesting tool, which, by the way, we created on top what is called intelligent performance. So in the portal, based on this data, we are actually showing some dashboards that are pointing you to what are the queries that are impacting the most your database performance, and also index recommendations. So if there is a query which is performing badly because there are not good indexes on top of that, we are actually proposing which indexes to create and eventually which one to drop, because maybe they are not used and they are only for consuming server resources. Right? And then, of course, you can decide which one of these recommendations you want to apply in your server or not. Connection pooling. As I was saying, connection in Postgres are expensive, right? So in SQL Server, by default, you have like 32K max connections on a given server, no matter if the server is big or small or whatever. Again, the default in Postgres is 100. Out of the box. Then you can, of course, change it and so on. But every connection is consuming a ton of resources. It's, I would say, 20 to 30 times more heavy keeping a connection open in Postgres compared to SQL Server. SQL Server is around 20K, or at least used to be around 20K, and in Postgres is a lot more heavy for the system, right? So we are actually embedding into Azure Database for Postgres a well-known connection pooling system, which is called PG Bouncer. Right? So every instance of Azure Database for Postgres also has an instance of PG Bouncer that you can decide to switch on or to keep off by default, right? And PG Bouncer is a connection pooler, right? So it's basically multiplexing, is accepting a number of connections, and then is using a reduced number of connections down to the database. So it's more rare that you will, exhaust the number of native connections in the server. To give you an example, like if I remember correctly out of my mind, 2 vCore instance is giving you around 800 to 1,000 max connections as automatically configured by our service. With PG Bouncer, you can scale it to 10,000. Right, and that's definitely not a reason for kind of leaking connections, of course, because it will have an impact anyway. So make sure that you are keeping connections open as short as possible, execute your transactions, and then dispose it, blah blah blah, all the best practices that we know and love. But here you have a buffer in front of your Postgres that you can actually use to optimize connection management. Okay, so just to recap, in terms of Azure Flexible Server, we take care of all the hard stuff in Postgres for you, like high availability, disaster recovery, backups, tuning, and so on, right? And it's also, from an infrastructure perspective, we offer all the different kind of flexible configurations, VNet integration, private endpoints, firewalls, and a bunch of others. You can certainly do that yourself by deploying Postgres in a VM in Azure or in AWS or GCP, but it's a lot more work, right? And especially to keep your instances up and running and highly available. That's not a walk in the park, right? So I definitely encourage you to take a look at the managed service option because it's very helpful. By the way, in Azure we have a compute series called Burstable for Flexible Server, which is like $5 or $6 per month, and then you can use it to practice, and of course you can use it as part of the Azure free account. So it can be good for developing your app and try how it works. Okay, so we have a few minutes. So I was thinking about showing you something like, as I was saying, Postgres out of the box is actually providing, it's not the one that I was looking at. Here we go. So it's providing a benchmarking tool out of the box. It's called PG Bench. It's simulating a TPCC type of benchmark. And you can actually point it to your system, like I have this local system. You can say how many clients you want to simulate, how many parallel tasks or jobs you want to spin up, and the duration of your benchmark, and your basically the database that you are targeting, right? And what this is doing, once I give it my password, is basically starting to hammer my my database, and I can start monitoring things like this. IO top is, in my mind, is a great utility, and is giving you. So these are all the connections that are hammering my local Postgres instance, right? So it's basically accumulating what is the total disk drive write and read. This is a mostly write benchmark that I just set up. So you can see that it's like 20 plus 200 megabytes per second, and you can basically see all the different queries that are coming in, what are doing, like committing transactions, updating, and so on. And this is just one of the tools. Just wanted to show you a different one, which is PG Top. Let me see. Okay, so this is similar to the previous one, but instead of only showing IOs, this is also showing things like memory utilization, CPUs, and such. Right? So these are the interesting thing of these tools is that you can actually SSH into your production box and run these tools in production remotely, and capture statistics, save it locally, and then do the analysis and such, right? So this is not exactly as simple in different platforms. Another tool that I wanted to show you, if I can find my command line here. It's called PG. Cannot find it right now. Wait a second. My keyboard is getting crazy. Docker, PG Center, here it is. So I have it installed as a Docker container on my machine. And I'm connecting remotely to my remote server, and this is just to show you. Okay, so I'm connecting to my remote box, which is still running the benchmark. I can show, for example, what are the key weight types. In this case, there's a lot of locking because this is concurrently updating, the same table. I can, my local VM is running a 200,000 statement per second, right? So it's a pretty robust kind of benchmark right now. And what I can do here, I can, for example, take a look at what are, for example, the queries that are reading more database pages, right? Or writing more pages for the various databases and for the different connections that are operating on my system. I can see things like again what are the statements these are cut, but basically I can see the queries, and for each query I can see how many calls are hitting the database, how many rows they are reading, and so on. So super interesting tools that are free and available from the community. Again, I definitely encourage you to take a look at my GitHub repo. You will see a lot of these tools explained with very detailed documentation and so on. Okay, we are running out of time. Thanks, folks, for attending. If you have questions, I'm available here, and for the rest of the conference, I will be around. Thanks again.